marine heat waves, sea ice, now stratification. So I give you my...
And the microphone,
yeah. If you are.
Thank you. Yeah, it's going to be a bit more nerdy, go deep in the ocean. I didn't quite know this group and know what to talk about here, so I've constructed this in the way much of this. It relates to VB2 that we lead. It's transport, VB4 and 3 on VB2. Stratification maybe also into heat waves, because heat waves and stratification are, of course, two things of the same site. In the Labrador Sea, eddies are emanating out there. As you see, the eddy kinetic energy, which goes into these convection zones and re-stratifies the Labrador Sea after deep winter convection, which also linked with the deep mixed layer depths. And using sea gliders, we were first, I would say, to show that it's just freshwater re-stratification. These eddies are bringing buoyant freshwater into the Labrador Sea. This has received much attention in the Labrador Sea, but not so much in the southern Nordic seas. So this freshwater re-stratification, almost no information on Nordic seas. These are Nordic seas. I'm from here, actually, the Faroes down there. And we're getting this gift from the Arctic, East Greenland Current, down East Icelandic Current, subarctic waters rich in nutrients and zooplankton, and these big fatty calamite copepods, Calanus marshals, and Calanus hyperboreus. In the deep waters, but probably also in this shallow layer. And I'll show this section several times. We have indicators of the volume of subarctic water, like this one there, that changes a lot from year to year, or period to period. And you see also changes in these calamite species. So it's a highly changeable ecosystem, and the zooplankton community changed a lot of these water masses. But before I'll go to this stratified layer, we'll go deep down in depth. Here we see arc of loads, so it's a shock to hear that this is stopping now, because they're very useful to illustrate also the deep flows trajectories. This is Norwegian Sea gyre. These are down on 1,500 meters. This is 1,000 meters. You see how these deep flows come from the Iceland Sea and towards our waters. This confluence and this really strong flow down here, and this then spreads out into the Nordic seas and also down through the Fairbank Channel. This is the deeper limb of the AMOC. Yeah, this is our favorite section, hydrographic section, section N. And if you look at that, or first, also, this gyre is strongest exactly. We call it the Norwegian Sea gyre. It's a really strong feature there. And if you look now from the east, the Faroes would be up here, and this is the Faroe current, this Atlantic inflow. Then out here, we have something called the Norwegian Sea gyre rim, very strong, very deep current, where the sea floor is steep, goes from 2,000 meters down to 3,000 meters depth. This is during a situation when the NAO is strong, the strong atmospheric forcing, the gyre systems are strong. You see it's strong reddish colors. But years like 2003, when the atmosphere was completely the other way, it was weak, the gyre system was weak, then this flow system changes a lot. Strong, weak. And when it's weak, also the shape of these boundary currents, they slacken and kind of get wider. And often when we look at this section, this is the view that people that know this region will often just see this. This is the Atlantic inflow. This has modified North Atlantic water. But it lies upon a much more complex seascape of many water masses stacked upon each other. This is the index, or based on this one, it's called modified East Icelandic water, comes from the Iceland Sea. And then you see the other deeper ones down here. And these are the water masses that go towards, or that's the deeper part of the AMOC. This trash hat here, that's the new thing. It's very clear, but has never been discussed in the literature. And it lies over this Norwegian Sea gyre rim. And I just think this is what I'll focus on, and it's important also to describe this feature. So we have a marked low saline top layer located over the yeah, I did this. This is our section, Faroes to the left, and just the seasonality based on many data from the late 80s. In February, you have this picture that you have this Atlantic inflow that keeps these blue subarctic waters at bay away from the Faroe Islands. That might also be the case in June, but there are market changes in late summer and also during the fall. If you don't see it from back there, we have this really strong feature, a stratified layer. And it's kind of embarrassing that we have not described this feature yet, although we've seen it for these years. And then going into your word, I did this just a few days ago, just to see if there's any information on sea surface salinity. So I took this down from Copernicus. I don't know really the quality of this, but it looks good. And if you look at the seasonality, we see again February and then summer. And then you see into August that it gets greener. Here it's kind of reddish, it's the Atlantic inflow, but it dilutes as we go into late summer and fall. So down there we go below 34.9, which is rather subarctic. And the Icelanders, they gave me this data 2 days ago to see what happens here in northeast of Iceland, where we have the source. These are all the sections from 2014 to 24 of their salinity sections. And we see that there is a strong fresh layer in August, about 50 meters deep, and then it goes down to 50 to 100 meters deep, and it's most pronounced during summer and fall. And there's also interannual variability in this. These are 10 years, so some years it's maybe down to 34.2, and then it gets in other years higher, so higher variability. So this is sea surface salinity in autumn when it's mostly the freshest, and then we see before 15 or after 2015. We heard about this cold hole and the AMOC and so on. And if you ask me, it's the subpolar gyre. SPG is the subpolar gyre. Convection started again, and it expanded again. That's why it becomes fresher after 2015. And after 2017, this EIC, the East Icelandic Current, also came. So it's much more subarctic due to two major drivers, the subpolar gyre and the East Icelandic Current. And if you look at the composite salinity in autumn, we see there's a huge difference here. It's much more bluish. And we see the influence of the subpolar gyre down here, and also it's much greener. And we also see this blueness goes all the way onto the Faroe slope. So we're not as shielded by Atlantic waters now in the last 10 years or so. And if you look at this section here from, again, in the east, this is in November in 2020, we see a Faroe current that's very slim. It's not really a broad one. There's dual core, which we have not seen before. Were registered. One of the cores comes from Iceland. And then we have these fresh waters that are coming very close to the Faroes. And the only study that has discussed this is this study here. So actually waters just from the Iceland slope and getting very close to the Faroe slope. So we're not shielded from Atlantic waters, and this is much more pronounced when the subpolar gyre is strong and it is Icelandic current strong, more subarctic influence. And these are so close to our shelves, so if you have some strong northerlies, it's imaginable that that material will actually go onto our shelf. So that's where we also have some connectivity between these shelves. And does it happen in reality? Yeah, if you just look through some drifters, surface drifters, you see many of those. They actually come from Iceland. I just take those from east of Iceland, and we see how many of them just come down and actually enter our shelf also. And it's rather swift. This kind of autostrada on the surface, it just takes less than a month to come from Iceland to the Faroes, which can bring zooplankton and, for example, also this species is a pelagic fish species. It's the most important species for the Icelanders. And the juvenile fish in the fall, they are located here. And could they also come onto the shelf? Maybe. The dark blue here is this modified East Atlantic Water Index. So when it's up, this forms Arctic, and this is a recruitment, how many young fish come to this fish stock. I don't say they're related, but they are similar. And we see it increase after the early 2020s. And then we also started to see this fish on the Faroe slope. Normally, we don't consider that fish to be a part of our ecosystem. And if you take a catch index, you see in the 20s, we got really a major boom of this fish coming to our ecosystem. And it happened here, but it has also happened before. And during these times, we actually see that seabirds and so on, they start to take this in addition to sandy. So they can be a really important contribution. So this fresh link or layer is probably very important ecologically, obviously in the open ocean, but maybe also on our show. So where do we go from here? This is also brand new. It's actually I've stolen or borrowed Stefan's clever student. She's called Ilana, to make use of ocean reanalysis. We use glories and particle tracking, so just starting this to see where they flow. And we have to refine this analysis. So this was from Iceland towards the Faroes, and these fresh waters, they also come all the way to or seen in Norway. This is the favorite section in Norway called the Swedish section. You see the Norwegian coastal current, and you see the freshness that goes far over here also. So they also get this emanation from all the rain that comes down here. And at this ocean weathership M, we see this is a surface salinity for many years. They measured every day. You see these drops in salinity. And also a study by Tore Furuvik. This is correlation between sea surface salinity and salinity at depth. So here it's correlated, but when you come into the summer months, June to October, then it becomes vertically disconnected. So the sea surface is disconnected from the Atlantic inflow from a large part, or for a large part of the season. And it is also imaginable that some years that the Norwegians might also get the influence all the way from us. So there's a kind of a mixing of this autostrada on top, which might blur this downstream, Atlantic downstream flows, connectivity, and also introduce some more zonal connectivity in this region. Because you're talking by interdisciplinarity in this group, I'll just take this last one. Because how can we actually go into policy? We don't have to invent things, because ICES, they have, for example, these ecosystem groups that are doing these things. And I'll take over as the chair of this group here, the working group of integrated assessment of the Norwegian Sea, now this fall, where we are interacting with stakeholders. People are coming from the big fishery and also the fishery ministers and bankers and so on that we do talk with. This group in Iceland is also established. I'm also a part of this one. And this project will start next week, which are wrapping all these ecosystem groups in ICES in order to do the science policy interface for sustainable pelagic fisheries. So what I'm trying to say, we're going to have, I think there's a great potential for synergy between this group and the others and those ICES groups. We have an annual meeting in November in Bergen, and this group really needs your capability, for example, when it comes to heat waves that could complement this. And I think this group could use this as a venue to really go into where it matters. And we are talking about billion-dollar industries. These are the largest fisheries in Europe. Thank you.